Today I'm going to explain to you how to find the area bounded by two parabolas. Y is equal to 6x minus x square and y is equal to x square minus 2x using the formula that the integral the area bounded by the given curve, the x-axis between x is equal to a and x is equal to b. That one is bounded by just a single curve and the x-axis between x is equal to a and x is equal to b. But in this case it is bounded by two curves, so we have to reduce this one also to that form in order to get the required area bounded by these two parabolas. So first step what you need to do is you construct a table for this one curve. Y is equal to 6x minus x square. So this is a table x and y. When x is 0, you'll get y is equal to 0. When x is equal to 1, then y will be equal to 6 into 1 minus 1 square will become 5 and so on. So for the second curve also, y is equal to x square minus 2x. You construct a table, then you'll get these points of or the coordinates in the xy plane as 0, 0, 1, minus 1, minus 1, 3. You substitute it here, then you'll get this table. Now what you need to do now, you draw the graph of this two curve. First, to draw the graph of this one, y is equal to 6x minus x square in the xy plane. So this is the y-axis, this is the x-axis. Now let us plot this point. When x is 0, y is 0. So it will be this point. When x is equal to 1, y is equal to 5. So it will be somewhere here. When x is equal to 2, then y is equal to 8. So this is that point. When x is equal to 4, y is again 8. When that means it will be, this is 3, this is 4. So it will be here again. When x is equal to 6, y is equal to 0. So it will cut this. Now if you join this one, you'll get a curve like this, a parabola. So this is represented by y is equal to 6x minus x square. Now next, you draw the graph of this one, second curve or second parabola, y is equal to x square minus 2x, using this point from that points from that table. When x is 0, again we have y is equal to 0. When x is equal to 1, y is minus 1. So let me mark this point as minus 1 here, this minus 2. So when x is equal to 1, y is minus 1. So it is here. When x is equal to minus 1, then y is equal to 3. It will be here. Then when x is minus 2, y is equal to 8. So it is this point somewhere here. When x is equal to 4, y is equal to 8. It will be this. So you'll see that if you plot this point, you'll get a parabola like this. When x is equal to 2, y is equal to 0. So it will cut the x-axis at the point 2, 0. So this is the graph of y is equal to x square minus 2x. So that means I need to find this area here bounded by this parabola y is equal to 6x minus x square and y is equal to x square minus 2x. So this will be the shaded region. So what you need to do now, through this line x is equal to 2, you draw a line which passes through x is equal to 2 and parallel to the y-axis. It is this line. And through x is equal to 4 also, which is the point of intersection of these two curves here. So you draw another line which is parallel to the x or the y-axis. So now what we need to do now, we need to find this area. This area plus this one plus this area here, which lies below the x-axis. But we know that now, you see that if I consider this whole thing in this way, we did not have a direct formula to evaluate the area bounded by two curves. We have only the area formula for finding the area bounded by a curve, the x-axis between x is equal to a to x is equal to b. So what we need to do now, for the time being, we can omit this region which lies below the x-axis. So I can consider this one. So what I can do now to find this area, you see that it is bounded by this curve and this curve. So now in order to reduce it to that for integral y dx from x is equal to a to x is equal to b, that is bounded by a single curve and between x is equal to a to x is equal to b, what you need to do now, you have to include this region. So it will be the area bounded by this curve y is equal to 6x minus x square between x is equal to 0 to x is equal to 4. That means it includes this region also. this region which is not supposed to be included, but later on you'll see that we will subtract that one. So it will be the area bounded by the curve y is equal to 6x minus x square between x is equal to 0 to x is equal to 4. Plus, now consider this area. What is this area? It is bounded by which curve? It is bounded by a single curve and the x-axis. Y is equal to x square minus 2x between x is equal to 0 to x is equal to 2. Then I need to subtract this one. Now this region here is bounded by which curve? It is bounded again by this curve y is equal to x square minus 2x, and the x-axis between x is equal to 2 to x is equal to 4. So on subtracting this one, then you'll get the required area, that is this region here. So now if I denote this one as A, P, this as O, this as B, L, then C, then what will be the required area? Now from the figure, area is equal to area of the region APOBLC, APOBLC, and this can be written as area bounded by the parabola, that is this one, parabola y is equal to 6x minus x square between x is equal to 0, okay, and the x-axis between x is equal to 0 to x is equal to 4. But you see that I include this region also, which is not a required region, but I'll subtract it afterwards. Then plus, now I need to get this area which lies below the x-axis, and this area is bounded by which curve? Bounded by the curve y is equal to x square minus 2x. The x-axis between x is equal to 0 to x is equal to 2. So plus area bounded by y is equal to x square minus 2x and this x-axis between x is equal to 0 to x is equal to 2. But now I need to subtract this one. So you see that this curve here, that is this one. So let us subtract this one. Now you can see that this region represented by the blue colored region, this is bounded by this curve, pink colored curve, y is equal to x square minus 2x, and the x-axis between x is equal to 2 to x is equal to 4. So you can write now minus area bounded by y is equal to minus, it is x square minus 2x, the x-axis, this one, x-axis between x is equal to 2 to x is equal to 4. So this is the required area APOBLC. So now what is the area bounded by the parabola, this one? So we have to use that formula, integral a to b y dx. So let us apply this formula now. So for the first one, it will be equal to integral 0 to 4 y dx. But what is y? It is 6x minus x square. 6x minus x square dx plus area bounded by y is equal to x square minus 2x. The x-axis between x is equal to 0 to x is equal to 2. So it will be integral 0 to 2. What is y? It is x square minus 2x dx minus the area bounded by this curve, that is this blue region here. So it is bounded by the curve y is equal to x square minus 2x. So it will be integral 2 to 4 x square minus 2x dx. So this is the required area of the region, that is this region APOBLC. So it is a simple integral only. So on integrating, you will get this result. You'll get this value 3x square minus x cubed by 3 is from 0 to 4, plus the second integral, you'll get this one, and the third one will be this one. Now what I'm going to show you, that you'll see that somewhere here you'll get this one, minus 4 by 3. Now this minus 4 by 3, you'll get it from the second term, that is this one. So what you need to do now is, since the integral is, since area is a positive quantity, so we have to consider it as plus 1. So we can omit this minus sign and write it as plus 4 by 3. Then minus of, that means minus of this area, and here this one also will get it as a positive value. It will be 20 by 3, but since minus sign is there, since we have to subtract that extra region, so it will be minus 20 by 3. It comes out to be 84 minus 20 by 3 equal to 64 by 3 square units. You can check from the notes also. I have already mentioned regarding this one, why we take the positive value of 4 by 3 instead of minus 4 by 3, because area represent, since area is a positive quantity, so that's why we consider it as plus 4 by 3. Hope it is clear now how to find the area bounded by the parabola y is equal to 6x minus x square and y is equal to x square minus 2x.